Hello, my name is Ben Joe. I'm the VP of Business Development at LuneWave. Thank you for your time and the opportunity to provide you with an overview of our company. The core of our company is the Lundberg lens antenna, which we have utilized to develop a disruptive automotive radar sensor. At the heart of LuneWave's technology is a patented process to cheaply and reliably 3D print a high-frequency Lundberg antenna that enables unprecedented capabilities. No other company in the world has been able to fabricate these lenses at scale for millimeter wave high-frequency applications. Our expertise has been developed through a decade plus of research and development in all aspects of lens design, fabrication, scaling to volume, and quality control. In addition, our company is backed by 8 VCs and 3 strategic investors: BMW iVentures, Shanghai Automotive, or SAIC, and Baidu Ventures. The Lundberg lens technology also has applications across a very broad set of industries. Because of its unique properties as an antenna, it can enable system-level solutions for any applications that require object detection and/or information transfer. These include automotive and 5G telecommunications, among others, as you can see. Our company is headquartered in Tucson, Arizona, and currently employs a team of about 25 employees. The leadership team brings many years of expertise in the automotive industry and 3D printing, as well as broad functional expertise across business development and engineering from industry-leading Fortune 100 companies. In addition, we are supported by a top-notch set of advisors with decades of leadership experience and who have held executive positions at companies such as BMW, General Motors, Aptiv, and Ford, to name a few. So what problem are we trying to solve? Well, today's sensors are not sufficient to address the needs of next-generation ADAS or autonomous vehicle applications. From a business standpoint, this means each vehicle is often equipped with 25 to 30 sensors as part of an ADAS package. Specific to radar, while it is the best modality in terms of performance in poor weather, today's radar sensors simply cannot see in enough detail and have very limited field of view. As a result, significant coverage gaps still exist, even with 16 or more traditional radar sensors installed on a vehicle, which is what we see today. Our solution then combines our 3D printed Lundberg antenna with proprietary algorithms to deliver a radar sensor system that will help the industry set new standards in performance. This means never before achieved levels of detection range, field of view, and angular resolution. With our solution only needing 2 to 4 sensors on a vehicle, LuneWave provides auto OEMs and other customers with unprecedented performance, along with significant cost savings by reducing complexity, saving space on the vehicle, and again, reducing the number of sensors. We continue to gain traction across a strong customer pipeline, cutting across every automotive segment, traditional OEMs, ride-hailing companies, AV, full stack, and last mile delivery. We've successfully completed multiple pre-development and proof of concept projects with many of the leading companies in the industry. And from a go-to-market standpoint, we are in the process of discussing strategic partnerships with global tier 1 suppliers for mass production. We're currently raising a Series A round, have an executed term sheet in which several existing investors are committing to super pro rata. We have about $2 million of capacity left in the round, which we expect to complete within the coming weeks. If you have interest in speaking to us further, we'd like to funnel you to John Shin, our CEO. His contact information is listed there. His email is john@lunewave.com. With that, I want to thank you again for your time and your attention. We want to wish you the very best in terms of safety and health, given these very difficult times. And again, we very much look forward to hearing from you. Thank you very much.
Perfect. Thank you. And I believe we do have John from LuneWave, right?
Hi. Good morning. How are you?
Good, good. Thanks for joining us. Hopefully this finds you in good health. Everyone is as Ben said, safe and healthy.
Yeah, it is certainly the new norm. I do want to mention trying to do our portion. We've set aside some capacity with our commercial grade 3D printers and already started to print out some medical devices and donating to local clinics and also hospitals, trying to do our portion.
John, that's definitely fantastic. I know we all need some help there. To jump into some questions before we have to move on though, can you talk around kind of the sensor cost itself, maybe what it is now or what you're looking to achieve in the future?
Sure, of course. I think the way to think about LuneWave's radar sensor, in general, radar sensor are very, very cost efficient for automotive, low cost. And I think when you look at LuneWave sensor, the way to think about it is really three components. One is the Lundberg antenna. The second is our proprietary algorithms. And then the rest, I call it the traditional silicon technology. So the antenna itself is actually a fraction of the BOM. And so in general, without sharing with you the exact numbers, the cost structure is very comparable to what the radar sensor is today.
Okay. And that kind of leads into the next question too. How does your tech, with LuneWave compare to solid state LiDARs?
Yeah, so fundamentally, it's a different technology. LiDAR, I think LiDAR camera, great technology, right? I think the short of it, though, is during poor weather condition, I mean, LiDAR is still considered a light spectrum sensor. So the scattering effect of just pure physics, they're not going to be able to overcome. So during poor weather conditions, LiDAR will struggle a bit. And, I think this is where it's known in the industry, radar is here to stay. So, we're really, trying to help the OEMs and tier ones to set the new standards in the radar space. As the presentation alluded to, I mean, I think the one takeaway from a lot of great traditional radar sensor companies and startups, but fundamentally 99% of them are using what's called a planar phased array, which creates that, what I call a tunnel vision. So right in front of the sensor gets the best performance. As you move outside that 5 to 10 degrees, distance decreases, clarity drops significantly. That's the reason that from a business standpoint, you need multiple radar sensors today to cover the vehicle. Whereas for us, that field of view is a design parameter. So that distance, 300 meters, 0.5 degree angular resolution, the top of the line resolution that's consistent across every degree.
John, awesome. Thank you so much for the insights and definitely information for all of us. Really appreciate your time and stay safe.
Thank you. Appreciate the opportunity.